We continue the lecture. Expand f z is equal to z square minus 4 upon z square plus 5z plus 4 in power sub z for first modulo z less than 1, second 1 less than modulo z less than 4, and third modulo z greater than 4. Solution we have fz is equal to z square minus 4 upon z square plus 5z plus 4 is equal to z square plus 5z plus 4. Here z square minus 4 only, we add this 5z here and subtract minus 5z. Here minus 4, therefore here plus 4 minus 8, that is minus 4 upon z square plus 5z plus 4. Divide after division is equal to 1 minus 5z upon 8 z square plus 5z plus 4. By partial fraction we get 1 minus 1 upon z plus 1 minus 4 upon z plus 4. For first, modulo z less than 1 we have modulo z upon 4 less than 1. Therefore from 1 modulo z less than 1 we have naturally modulo z upon 4 less than 1. We express this in z upon 4 form. Therefore from equation 1 fz is equal to 1 minus 1 upon z plus 1 minus 4 upon z plus 4. Is equal to 1 minus 1 upon 1 plus z minus 4 upon 4 into 1 plus z upon 4 is equal to 1 minus 1 upon 1 plus z minus 1 upon 1 plus z 1 plus z upon 4. Take outside the bracket 4 get cancelled. Is equal to 1 minus summation n goes from 0 to infinity minus 1 raised to n z raised to n minus summation n goes from 0 to infinity minus 1 raised to n in bracket z upon 4 raised to n is equal to, because we know that 1 upon 1 plus z, that is 1 minus z plus z square by 2 minus, therefore 1 minus is equal to 1 minus summation n goes from 0 to infinity minus 1 raised to n is common to both and summation is common to both, therefore 1 z raised to n is common, therefore 1 plus 4 upon n into z raised to n is equal to 1 plus summation n goes from 0 to infinity minus 1 raised to n plus 1 in bracket 1 plus 1 upon 4 raised to n z raised to n when modulo z less than 1. Second, for region 1 less than modulo z less than 4 we have 1 less than modulo z and modulo z less than 4. Therefore, we express this as modulus 1 upon z less than 1. 1 less than modulus z, that is 1 upon modulus 1 upon z less than 1, and modulus z upon 4 less than 1. Therefore, fz is equal to 1 minus 1 upon 1 plus z minus 4 upon z plus 4 is equal to 1 minus 1 upon z into 1 upon in bracket 1 plus 1 upon z minus, take outside the bracket 4 into the denominator, 4 into 1 plus z upon 4 get cancelled, is equal to 1 minus 1 upon z minus 1 raised to n 1 upon z raised to n minus, for this 4 get cancelled, summation n goes from 0 to infinity minus 1 raised to n z upon 4 raised to n is equal to 1 plus summation n goes from 0 to infinity. Here minus 1 minus becomes plus s raised to n, 1 raised to n plus 1. We put this into the summation, therefore 1 upon z raised to n plus 1 plus n goes from 0 to infinity minus 1 raised to n plus 1. We put this negative sign in the summation, therefore minus 1 raised to n plus 1 z raised to n upon 4 raised to n. Thus fz is equal to 1 plus summation n goes from 0 to infinity minus 1 raised to n plus 1 and summation is common. Therefore 1 upon z raised to n plus 1 plus here z raised to n upon 4 raised to n where 1 less than modulo z less than 4. Third, for modulo z greater than 4 we have 4 less than modulo z. Therefore modulus of 4 upon z less than 1. Therefore naturally 1 upon z less than 1. There since 1 less than 4 less than modulo z. From equation 1, fz is equal to 1 minus 1 upon z plus 1 minus 4 upon z plus 4. fz is equal to 1 minus 1 upon z, 1 upon 1 plus z. We take outside the bracket into the denominator z. 1 upon, we get 1 upon z, 1 upon in bracket 1 plus 1 upon z. Minus 4 upon, we take outside the bracket into the denominator here z. 4 upon z in bracket 1 plus 4 upon z is equal to 1 minus 1 upon z summation n goes from 0 to infinity minus 1 raised to n. We know that 1 upon 1 plus z is equal to minus 1 raised to n z raised to n. Therefore here summation n goes from 0 to infinity minus 1 raised to n in bracket 1 upon z raised to n minus 4 upon z summation n goes from 0 to infinity. We know that 1 upon 1 plus z, that is minus 1 raised to n z raised to n. Therefore here 4 upon z summation n goes from 0 to infinity minus 1 raised to n 4 in bracket 4 upon z raised to n is equal to, we put this negative sign in the summation and z 1 upon z into the summation. N goes from 0 to infinity minus 1 raised to 1 n plus 1 1 upon z raised to n plus 1 plus summation, here we put this minus sign here and 4 upon z here plus summation n goes from 0 to infinity minus 1 raised to n plus 1 4 raised to n plus 1 upon z raised to n plus 1 is equal to 1 plus summation n goes from 0 to infinity minus 1 raised to n plus 1 is common to both and 1 upon z raised to n plus 1 is common. Therefore only 1 plus 4 raised to n plus 1 in bracket 1 plus 4 raised to n plus 1 multiply by 1 upon z raised to n plus 1 where modulo z greater than 4. Expand z square minus 2z plus 5 into z minus 2 into z square plus 1 in the annulus 1 less than modulo z less than 2. The given annulus is as follows. Modulo z is equal to 2, 1 less than modulo z less than 2. Consider z square minus 2z plus 5 upon z minus 2 into z square plus 1 is equal to 1 upon z minus 2 upon z square plus 1. By partial fraction, we get this by using partial fraction. Now modulo z less than 2 gives modulo z upon 2 less than 1 and 1 less than modulo z gives modulus 1 upon z less than 1. That is modulus of 1 upon z square less than modulus of 1 upon z less than 1. That is 1 less than modulo z less than 2 gives modulo z upon 2 less than 1 and modulus 1 upon z square less than 1. Therefore z square minus 2z plus 5 upon z minus 2 into z square plus 1 is equal to 1 upon z minus 2 upon z square plus 1 minus 1 half into 1 upon 1 minus z minus 2 minus 2 upon z square into 1 upon 1 plus in bracket 1 plus 1 upon z square. For this we know that 1 upon 1 minus z, that is z raised to n only. Therefore here 1 minus z upon 2. Therefore z upon 2 raised to n only. Minus 1 half is equal to summation n goes from 0 to infinity in bracket z upon 2 raised to n minus z upon 2 upon z square, summation n goes from 0 to infinity minus 1 raised to n in bracket 1 upon z square raised to n is equal to minus, we put this in the summation, minus summation n goes from 0 to infinity z raised to n upon 2 raised to n plus 1 plus 2 1 upon z square, put this into the bracket, minus n and 1 upon z square into the summation, plus 2 summation n goes from 0 to infinity, here minus 1, here minus 1 raised to n, therefore minus 1 raised to n plus 1, here 1 upon z square raised to n, here 1 upon z square, therefore 1 upon z square raised to n, that is 1 upon z raised to 2n plus 2. It's okay, we stop here.